Hey guys, so yesterday we did our special angles, but today we're going to do sine, cosine, and tangent, so the primary trig ratios of angles anywhere from 0 to 360. So we're looking at not just our 45, 30, and 60, we're looking at any of the angles that we have on our coordinate plane. So one thing to note, and if you watched the video from the other day, for any rotation angle in standard position that has point P, which is y and x, on its terminal arm, we have the following trigonometric ratios. So it's kind of like, I'm going to give you the definition. So we always go, our terminal arm always starts from the middle or the origin and goes out to point P. And that is our xy. Now, it's not always in this quadrant. It could be in any of these quadrants. But what's going to happen, so why I like the different colors, is we've got this side and this side, which makes a 90-degree angle, which is good for us. And it also gives us our, let's use a different color, our reference angle, or theta, in the corner there. So that is our reference angle. Now, what happens is that this is our x, that length is x, this length is y, and this length is r. Now, if you remember the Pythagorean theorem, you would know that in order to get r is the square root of x squared plus y squared. So a squared, b squared equals c squared. It's just another way to write it, but that length of that r, or the arm, is x squared plus y squared, and we take the whole square root of it. So you can easily figure it out. But what that means also is that sine of theta anywhere is equal to our x over r, cos, oh my gosh, I did that wrong. Let's go back. Sine is y over r. Cos is x over r. And which leaves us to have tan y over x. And we can use those to basically do any point on our circle, or anywhere in that quadrant, the quadrants, quadrant 1, 2, 3, or 4, anywhere on the quadrant plane. You can use your x value and your y value if you know the point. You can find out what r is, and you can calculate it. So that's a lot of what we're going to be doing today. And then we're also going to be kind of just using our calculators and just getting used to the fact that we have the cast rule, that this is where cos is positive, this is where all of them are positive, sine is positive in quadrant 2, and tan is positive in quadrant 3, cos positive in quadrant 4. So getting used to the cast rule, where do things lie, what's going to be positive, what's going to be negative, and just kind of using that for all angles from 0 to 360. Let's take a look at our example, and we'll see how this all works. Okay, so here's our example. The coordinates of a point on the terminal arm of an angle theta in standard position are -3, -5. Determine the exact primary trigonometric ratios for theta. So we're going to leave it in fraction form because they want exact. This usually means that we're going to leave it in fraction form. We might reduce it, but it needs to be in fraction form with the roots, if we have roots, when we take the square root. We're just going to leave it in those fractions. That's what that exact value means. They do not want it in decimal, which I know is kind of hard for some people just because they're so used to putting things into decimals. We're not going to do it with this if it tells you exact values. And you will lose marks if you don't do it properly. So please, when it says exact values, you put it into exact values. Some of the questions I say it's fine to put it into decimal, and that's perfectly fine because I said to do that. But otherwise, if I say exact value, just leave it as exact value. So 3 and -3, -5. So let's plot that point. -3, -5. That is here. I'm just going to draw it for the sake of showing you guys how it's going to work. Now, it is in quadrant 3. So right away, I think cast rule. What is positive in quadrant 3? Tan is positive in quadrant 3. It's okay to kind of write the letters on so you remember them. So tan is positive, which means cos and sine are negative. Now, this one, what's nice about this is I don't know what the angle is, but I'm just going to mark it on there. That is angle theta. That's our reference angle. It's the one that is closest to the x axis. But if we think about it, it's an angle that is between 180 and 270. But it's not asking for us to actually find the angle. It's just asking for the trigonometric ratios. So we're just going to not worry about what the angle is. However, since we've plotted it, we know that this is 3 long because that was our x. It just went in the negative direction. And this one is 5 long. Now, the one thing we have to find out is what is r. So the first thing to do, step 1, is to find r. So we're going to calculate that. And as I showed you before, r is the root of x squared plus y squared. So we can just get that. X is -3, so it's -3 squared plus y, which is -5 squared. Again, guys, it's just the Pythagorean theorem. 9 and 25, which is root 34. Now, because it wants exact value, I am going to leave it like this. That is our r value. And then all you have to do is go back, and we're going to do sine of theta, cos of theta, and tan of theta. Using our trig ratios of y over r, x over r, and y over x, and also our cast rule, which ones are negative and which ones are positive. So first, I'm going to do what I did last time. In this quadrant, I know that tan is positive, so that's fine. But cos is negative and sine is negative. So I'm just going to throw the negatives there already. Sine is y over r. So our y value is 5. Oh, excuse me, I'm putting that over the negative. 5 over, it's a negative, 5 over root 34. Because that was our r. Cos was x over our r value. And in our case, it's negative. So our x was 3 over root 34. Because we got that from there. And then tan is just our y over our x. Y was 5 and x was 3. And it's a positive because it's positive in that quadrant. And that, my friends, is how you do it. That's it. We're using Pythagorean theorem. We're using our cast rule. We're using SOHCAHTOA. And we're just leaving it as exact values. These are exact values. They're in fraction form. I haven't changed that root to anything because I can't. If I do, it's a whole bunch of decimals and it's not exact anymore. So just leave it like that. That's exact values. That's how it should look. A lot of your problems are going to look like this. And that's okay. You're just going to leave it just like that. Again, if you have any questions, let me know. Bye, guys.